So this is going to be our video number 2 on solving system of equations. So I'm going to walk you guys through an example that I think a couple people are having trouble on. I just want to review with you really quickly first about systems of equations, because there are some things that we would just kind of really need to know about them in order to help us solve problems like this. So I know at the top of the page I'd put something about a no solution system of equations, but just to review, basically a no solution system of equations happens when there's no intersection points. On those first couple of examples that I walked you guys through, I said, okay, every time we get an ordered pair, that's representing the intersection of the two lines. But what happens when they don't intersect? Well, that's a special type of system of equations. And when they don't intersect is basically when they're actually parallel lines. So a no solution system of equation is basically when the lines have a same slope but a different y-intercept. So for example, if I had a y-intercept up here of one line, maybe my line looks something like this, and I had a y-intercept here of the other line, but they were kind of going at the same angle, that's going to represent a no solution, because no matter how far up these lines go or no matter how far down these lines go, they're never going to intersect, so there's never going to be a solution or an intersection point. So a no solution system of equation basically is when the lines have a same slope but a different y-intercept. So keep that in mind when we're going through the example that I'm about to show you, because that's going to be an important concept that we need to remember. All right, so I'm going to give you a system of equations, which I'll write on my board. That's going to be, let's do x plus 3y equal to 4. And I'm going to make my second equation kx plus 2y is equal to 0. And basically what I want to know is, for what value of k does the system have no solution? So basically I want to know, what does k equal? Oops, what does k equal? K doesn't equal 0, sorry. For the solution to have no, or my gosh, for the system to have no solution. Okay, so basically that's telling us that our two lines are going to have the same slope, but they're going to have different y-intercepts. So the first thing that I'm going to do is I'm actually going to rewrite these two functions in y-intercept or slope-intercept form, so that I know exactly what my slope is and I know exactly what my y-intercept is. So I'm going to rewrite both functions. So basically that's going to tell me that I'm going to rewrite these in terms of y. So my first one is going to end up being 3y is equal to, I'm going to move the x to the other side, so negative x plus 4. The second one, I'm going to leave the 2y where it is, and I'm going to move the kx to the other side, so that's going to give me negative kx. And then I want to get the y by itself in both of these equations. So in my first one, I'll divide everything by 3. So that's going to tell me my equation would be y equals negative 1/3 x plus 4/3, because I have to divide both terms by 3. Same thing over here. This is going to be y is equal to negative 1/2 kx. All right, so that's going to be the system that I'm going to work with. And I'm just going to erase the board so I have a little bit more room to work with. But if you need to pause the video and write this down, you can go ahead and do that. All right, so my system that I want to know what value of k is that's going to make this system have no solution is going to be y is equal to negative 1/3 x plus 4/3, and y is equal to negative 1/2 kx. All right, so remember in slope-intercept form, y is equal to mx plus b. If we know these two equations need to have the same slope, I'm looking for this value in front of the x. So the value in front of the x in my first equation is negative 1/3. The value in front of my x in my second equation is actually negative 1/2 k, which basically means k is just some constant that we're multiplying by. So in order for this to have no solution, these slopes, this negative 1/3 and this negative 1/2 k, need to be the same, meaning negative 1/3 needs to be equal to negative 1/2 k. So basically, to solve this equation, I want to get k by itself. So what I'm going to do is I'm going to multiply both sides by the reciprocal of negative 1/2, which is going to give me negative 2 over 1. And I'm going to go ahead and do the same thing over on the other side of the equation, because everything's going to cancel out over here. So I'm left with negative 2 over 1 times negative 1 over 3 is equal to k. When I simplify that, multiply across, negative 2 times negative 1 is 2, 1 times 3 is 3. This is telling me that the value of k that will make that system of equations have no solution is going to be 2 over 3. All right, so that will hopefully help you with the problem that a couple people had asked me about on that worksheet. And the last problem that I'm going to do is going to be an application. We're going to be talking about a movie theater. So a movie theater sells tickets for $8 each, with seniors receiving a discount of $2. All right, so tickets are $8 each. Seniors are receiving a discount of $2. One evening, the theater sold 525 tickets and took in $3,580 in revenue. And basically what I want to know is how many of each type of tickets were sold. So I want to know how many regular tickets were sold, and I want to know how many senior tickets were sold. So what I'm going to do is I'm just going to first start to set some variables. So I'm going to say X is the number of regular tickets sold. And I'm going to say Y is the number of senior tickets sold. All right, so basically in order to have a system of equations, I need to have two equations. One of them is going to be representing the number of tickets, but we also have other information. We have the price of the tickets. We know that there are regular tickets sold at $8. We know that the seniors tickets have a discount of $2, and we have a price of $35.80 in revenue. So my first equation, it doesn't matter which order you write these in, I'm just going to kind of write them in the order that I have, like in terms of the variables that I've already set. I'm going to say my first equation has to do with the number of tickets. So it's telling me we've sold a total of 525 tickets, and I know that I have some number of regular tickets sold, and I know that I have some number of senior tickets sold. So my first equation is going to be representing some number of regular tickets sold plus some number of senior tickets sold, and the total number of tickets sold is 525. So this is going to be the first equation that I'm going to use in my system of equation. My second equation is going to be representing the price, because I have information on prices, and it's telling me that the regular price tickets are $8 each. So that's going to go with my X variable. So I'm going to write that as 8X. And then I need to take into account the senior tickets. So if I'm selling my regular tickets at $8 each and my seniors are receiving a discount of $2, that must mean that the senior tickets are $6 each. So that's going to go with my Y variable. So 6Y, and that's going to be equal to the total revenue that we're getting from this ticket sale. So that's going to be equal to the $35.80. So there's my second equation. So basically my system of equation is going to be X plus Y is equal to 525 and 8X plus 6Y is equal to 35.80. All right, so I'm going to erase this so I have some room to do some work, and we will actually figure out, well, how many regular tickets were sold and how many senior tickets were sold. All right, so my system, X plus Y is equal to, what did I say, 525? And 8X plus 6Y is equal to 35.80. So you can do either substitution or elimination on this one. Either one would be just as easy, because you could either solve for X or Y and substitute that into the second equation. I'm going to choose to use elimination just because I tend to like that a little bit better. I think it's a little bit quicker for me. So I'm going to multiply this first equation. I don't know, I'll get rid of the X's. So I'll multiply the first one by -8. And again, that -8 is going to be multiplied by everything in that first equation. So -8x minus 8y is equal to, let me grab my calculator, 525 times -8 is -4,200. And then that second equation is going to stay exactly the same. So 8x plus 6y is equal to 3580. And since I'm using elimination, I'm going to go ahead and add those two together. So the x's are going to cancel out. Negative 8y plus 6y is negative 2y. And then negative 4200 plus 3580 gives me negative 620. Divide each side by negative 2. The y value should be 310. And then to find the x value, plug back into either one of these. I'm going to use the first one because that's going to be easy. So x plus the y value of 310 is equal to 525. So I'll get rid of the 310. 525 minus 310 gives me 215. Oops, that's 215. Okay, so to answer the question, remember that the x variables represents the number of adult tickets or the regular tickets sold. So that means that there were a total of 215 regular tickets sold. The y value, remember, represents the number of senior tickets sold. So that would mean that the number of senior tickets sold would be 310. All right, so hopefully that helps you out with the last two problems on that SAT worksheet that I posted. Again, please make sure that you ask me if you have any questions.